So we have this question of maximum twin sum of a linked list. Now this question states that in a linked list of size n, where n is even, so length of the linked list will be even, that is given in the question. The ith node and is twin with n minus 1 minus I. The ith node, that is, let's say this is the ith node, is twin with n minus 1 minus I. This is n minus 1 minus ith node. So it question is saying that 5 is going to be twin with 1 and 4 is going to be twin with 2. Now we know the meaning of what twin is. Now the twin sum is defined as the sum of the node of its twin. Now the twin sum will be 5 plus 1 6 and 4 plus 2 6. Now given the head of the linked list, return the maximum twin sum of the linked list. So the answer, the value will be 6. This should be our value that we need to return. Now let's write the linked list first. We have 5, then 4, then 2, and then 1, right? Now what we have to first, we need to first calculate the length of the linked list, right? So we would know ki how much to iterate. The length will be simply 4, and we can easily calculate the length of the linked list by, let's say, let's create a new pointer to be variable and store the head into it. And while variable is not equals to null, so at the end it will be null, right? So not equals to null, we will keep a counter or a length, and initially we will put the length to 0 and increment the length and move the variable to the next node by val equals to val next, right? Now this code will simply calculate the length of the linked list. Now what we need to do is we need to find the maximum sum. So there are multiple ways of doing it. First way that comes to mind is, what if we have this linked list and we reverse it, right? And we reverse this linked list as following: 2, 4, and 5. Now simply what we are going to do here is that if we follow this approach, then we'll go to the half of the linked list and add all these numbers. You see, 5 plus 1, we had this 5 and 1, we'll add this 5 plus 1 6, and again we will add 4 plus 2, we got 6. We'll find the maximum value simply by calling out the max function, or we can simply compare max value and we can simply return the maximum value of it. Now this approach is a little space consuming, as we need to create another new linked list and we need to reverse it, and then we need to add both of this linked list and iterate half of the linked list over it. The best approach that I think to solve this problem is by using any different container like a vector or a stack. What we could do instead is a better approach would be, we had, let's say, 5 4 2 1, right? 5 4 2 and 1. What if I could store the half of the linked list onto any other container? The container could be a vector, a stack, a deque, or any other container as follows. Let's take a stack for this matter. Let's create a stack, right? We know the length of the linked list, right? Length to be 4. Now we will iterate half of the length, so we'll go 0, we'll go to 1, so we'll have the 0 1 2 3. We'll go to the half of the linked list and store the values into the stack. So we will have 5 and 4. Currently our pointer is here, right? We ran half of the length over it. Now our pointer is here. Let's the node pointer be named as variable, and variable contains initially head, and we iterated over it. Now the variable is pointing here. Here is our variable. Now the clever part is that what we are going to do is we are going to add, let me change the color. Now we are going to add this 2 with 4, right? See, we need to add 2 plus 4. Initially the question also we were adding 2 plus 4, right? We will add this 2, this 4 plus 2, and we'll calculate the sum. Then we'll add 5 plus 1, we'll calculate the sum, right? Now what we are going to do is, where's the color? What we are going to do is, now currently our variable is right here. What we are going to do is we are going to add these two numbers. How? we will type val.data. Val.data refers to this plus st.top. st.top. Now val.data plus st.top will give us 4 plus 2, which is 6. Now we are going to keep a variable maxi, let's say, and set the value to be -1. Now we are going to compare this value with maxi, right, and put it in a max function. Max function will output the maximum of these values. So val plus variable data, which is 2, plus 4, which is 6, is getting compared with -1. What will be our output? Our output will be 6, and we want to store this output into this maxi variable. So we store this into maxi. Currently our maxi has 6 into it. Then what we are going to do is we are going to move this pointer over here simply by doing var equals to var next. And also we need to remove this value from the stack so that we can add 5 plus 1, right? Initially we had, now we added 4 plus 2, now we have to add 5 plus 1. We have 1, our variable is currently pointing at 1, pointer is pointing at 1, now we need to point to 5. So remove the top element. Simply we can do st dot top. I'm sorry, st dot pop. st dot pop will remove the top element, and currently we will be pointing at this 5. Now simply we will add 5 plus 1. Okay, so the loop will again run. Val data will point to 1, and we will add it to with 5, so the value will be 6, and maxi contains 6, right? So 6 is getting compared with 6, the maximum value will be 6, and maxi will again contain 6. So at the end, when so we need to run this, and we need to put everything inside a loop, right? Now the loop will run while variable is not equals to null, right? After getting into 1, we have what? Null. Now once it encounters null, we need to break, and we got the maximum value of the maxi, and this will be our answer. Now let me clearly write the code so that you can understand. So what should be our first step? The first step should be, let's draw the linked list again. Let's take a different example. Let's say 7 1 4 2, right? Now let's manually calculate what should be our answer. 7 plus 2 will add these two number and these two numbers, right? 7 8 9 and 4 1 5. So clearly the maximum is 5. This should be our answer. What should be the first step of solving this problem optimally? You can solve it in different ways. You could reverse this and add it to it, iterate over half of the linked list. But what I'm going to do is, using stack, cleverly we will store just the half of the linked list. What we are going to do first is calculate the length of the linked list. Let's take an example of, let's say, node star temp is equal to head. Now temp is pointing over here, right? Now while temp, you can simply write while temp. It will also work, because while null will exit the loop, or you could type while temp not equals to null. Both will work, as this will also work, because while null would equivalent to 0, so while 0 will exit the loop. While temp, that simply means that while temp is not equals to null, what we are going to do is move the temp variable, move this temp pointer to the next node, temp next, and we are going to maintain a counter, let's say length, and do length plus plus, right? Now this much part of the code calculates the length of the linked list. The length will, after this, the length value will be 4. But remember, the temp will be at the last, at the null point. Temp will be here, right? Then we need to set the temp to head again, so that we bring the temp over here, correct? We bring the temp over here. Now what we need to do? We need to, as we know the length of the linked list, we will store the half of the linked list into stack. So the first half of the linked list we are going to store into stack. So we'll store 7 and 1 into stack. Let's say the name of the stack is st. Now how do we do it? It's really simple. Simply run a for loop. So let me change the color. We'll have a for loop for int I is equals to 0 and I is less than length divided by 2. Length divided by 2 will give us 2, less than 2, 0 and 1. Okay, the 0th and 1th node we will insert it into the linked list and I plus plus. Now what we are going to do is we are going to insert it into our linked list. I'm sorry, we are going to insert the value of the linked list into the stack. So what we are going to do is st dot I think push, we are going to st dot push. What we are going to push? We are going to push where data, right? Now once we are pushing it into the stack, we need to move the variable. Okay, I'm sorry, I took it temp, right? So we will write temp data. It will be temp data. Now we need to move the temp to the next node. So we will simply do temp is equal to temp next, right? This part of the code, just this part of the code, simply puts 7 and 1 into the 7 and 1 into the stack. Now currently our temp is not here. It's not here. It's currently in the next half of the linked list. It's currently here. What in this part of the loop, what we are going to do is we are going to add it to the topmost element of the stack and find the maximum. So what we are going to do is run a loop. Let me write it here. It's lack of space. Run a loop. We will run while temp. So we could write while temp not equals to null, or we could simply write while temp. It will work. While temp, we will find the maximum value. Maximum value of what? Maximum value of the maxi that we initially set to -1. So maximum value of the maxi and temp data. Temp data will fetch us. Temp data will here. Temp data will fetch us 4, and we need to add 4 to the topmost element of the stack, right? So temp data plus st dot top, right? So this value we are going to compare with maxi, which is -1. Now temp data dot st dot top gives us 4 plus 1, 5. 5 and -1 is getting compared. Max function will return 5, and we need to store this 5 into maxi, right? So we'll store it in maxi. Simply the -1 will get omitted and replaced by 5. Now we need to move temp to the next node. Temp next, right? And once we move temp into the next node, the other thing that we need to do is we need to remove the topmost of the stack. So simply write st dot pop. St dot pop is a constant operation which will remove the topmost element of the stack. Now our top is 7. Okay, now our top is 7. Now 7 is going to be added with the temp which is moved to at the end. 7 is going to be added with 2, right? 7 is going to be added with 2. It gives us 7, 8, 9. Now 9 is getting, now we have 9. 9 is getting compared with maxi, which is 5. So our current maxi will be 9. And we are going to move temp to temp dot next. Now temp dot next gets us to null, right? We have temp pointing to null, so it will break the loop. What is the value of maxi currently we have? The current value of maxi is 9, right? Maxi current value we got 9. This is our answer when we just return the maxi. Return maxi. And done. We used just stack. You could have used a vector to iterate half of the linked list. All right. You just iterate half of the linked list. The basic idea of my approach is iterate half of the linked list, store all the half of the linked list data into a stack, and then keep comparing with the other half of the linked list and find maximum. I'm going to show you the code. Okay, so this is the code. See, initially this line, this part of the I'm sorry. So this part simply calculates the length of the linked list. Let's say length is 4, right? Now we are setting the temp was null after calculating the length, setting the temp again to back to head, and this part, specifically this part, iterates over the half of the linked list. If the linked list was this, we are iterating over half of the linked list, half of the linked list, and storing the values into stack. See, we used st.push and pushing all the values into stack and moving temporary. Now, the variable temporary, or the pointer which is pointing to the node, will be here, right? Then what we are going to do is we are going to run another loop which is going to iterate over the next half of the linked list, and comparing the values of this stack, it is going to calculate the maximum. See, we are calculating maximum. Maxi is initially set to -1, and we are adding temp val plus st.top, adding the topmost element of the stack and the frontmost element of the second part of linked list, and we are adding it and finding the maximum. Then we will pop the pop the topmost element of the stack and move the variable from the second half of the linked list, and keep iterating and finding the maximum element, and at last we'll return the maxi.